All right, welcome back to another session where I work out your homework. We're talking about solving quadratic inequalities, and hopefully you can learn something. So let's get it. All right, number one is 2 negative 10 a solution to the inequality y is greater than or equal to negative x squared minus 5x plus 3. All right, so that's my x and y. If I plug these values into the inequality and I analyze to see if it's true or not. So let's see. Negative 10, right, because that's y, greater than or equal. Negative x is going to be 2 squared, in parentheses, minus 5, 2, 3. Okay, we're just simplifying. So this is going to be, so notice here, right, this negative is this negative. The square only applies to the 2. So 2 squared is 4. So negative 4. Minus 5 times 2, which is 10, plus 3. And this is all less than or equal to negative 10. Okay, negative 14 plus 3. What is this? Negative 10 greater than or equal negative 11. So is negative 10 greater than or equal to negative 11? Well, let's think about it. On the number line, right, if 0 is here, negative 10, negative 11. So 10 is to the right, so yes, it is greater. This is true, so this is true. All right, since this is true, the answer to this question is yes. Is this a solution? Yes, it is. All right, number 2. Is 0, 5 a solution to the inequality? Y is less than 4x squared minus x plus 5. So again, x and y, we're going to substitute these values into the inequality. So 5 is less than 4x, which is 0, that's nice, minus 0 plus 5. So right away, 0, 0. So is 5 less than 5? No, it's not. It's equal to 5. So this is not true, right? This is false. Therefore, this solution is not a solution. Is this a solution? No. The answer is no. It is not. All right, number 3. Y is greater than or equal 5x squared plus 10x plus 5. So here we're going to graph this. We're going to graph the inequality. All right, first thing I'm going to do is kind of disregard this for a moment. Let's just graph the parabola. I know it's going to open upwards, so let's figure out some of the details. So some useful information. Useful information is going to be, right, the vertex, the x component of the vertex, and then I'll plug this value in here to get the y component. The c value is the y-intercept. And then the x-intercepts, if it's factorable, we can factor it. Okay, so let's see. Let's just start with the vertex. So this is A, this is B, and this is C. Negative B, which is 10, over 2A, which is 5. So this is going to be negative 10 over 10, which is basically negative 1. I take negative 1 and I plug that back in. So this is going to be negative 1 squared. That's 1. That's nice. This is basically -1. So I'm going to get 5 minus 10 plus 5. Okay? So 5 and 5 is 10. 10 minus 10 is 0. So that means that at x equals -1, here's the axis of symmetry. Somewhere on this dotted line is the vertex. Well, at y equals 0, there's the vertex. Does it open up or down? It opens upward, and it crosses the y-axis at 5. So there's 5. I can go ahead and reflect this point across the axis of symmetry. It's going to look something like this. Okay, it's not, it's ballpark. Okay. And now we decide, I guess one of the things I glazed over, so greater than or equal, right? Greater than or equal, that's a solid line. And if it's strictly less than or equal, or less than or greater than, right? So these symbols, it's a solid line. These symbols, it's a dotted line. Okay. Now we determine where do we shade. Do we shade inside or do we shade outside? Now there are a whole bunch of different ways that you can remember this. I like to choose a point and I test it against the equation. And if it's true, if it satisfies the equation, I shade on the side that the dot is on. When I say side, there's the outside the parabola and inside the parabola. So the point that I'm picking is 0, 0. Do yourself a favor and pick the nicest point. So what's going to happen is, right, x and y. So 0, all this becomes 0. So is 0 greater than 5? No, it's not. 0 is smaller than 5. So it's a false statement. So I wouldn't shade out here. I shade opposite. I shade inside. Right. It just so happens that the point I chose is outside. Okay, number 4. Y is less than or equal. So right away I know it's solid. Negative 2x squared plus 4x minus 1. Opens downward because it's negative. Crosses the y-axis at -1. So these are some things to kind of think ahead. Okay, first thing I'm going to do is figure out the x component of the vertex. So negative b, which is 4, over 2a, which is -2. So this is going to be, so negative and negative are going to cancel. 4 over 4, which is 1. So the x component is 1. At x equals 1 is the axis of symmetry. Somewhere on this line is the vertex. Where? That is the question. So since x is 1, I plug it into the OG equation. 1 is nice, right? 1 squared is just 1. So this is going to be -2 plus 4 minus 1. So -3 plus 4 is 1. So that means at y equals 1, on the x equals 1 dotted line, this is where the vertex is. And it opens downward. And it crosses at -1. So at -1 is going to cross y equals -1. We can reflect this across the axis of symmetry. So I know that it's going to look similar to this. And it's a solid line. That's what we said. So let's see. Do we shade outside or inside? I like to pick 0, 0. This is outside. So if it satisfies this equation, we're going to shade the outside part. So let's see. 0, 0, 0. So is 0 less than or equal to negative 1? Well, here's 0, here's negative 1. 0 is greater than. So this is a false statement, right? It's not true. This is false. So I don't shade out here. I shade in here because it's false. Number 5. Y is less than, so it's going to be dotted, negative 5, 4 minus x minus 4 squared plus 6. So right away, this is vertex form, right? This is vertex form. So this is HK. So the vertex is at 4, 6. So 4, 6. It's negative, so it opens downward. So let's figure out the details. We're going to have to expand this out. So I want to figure out where it crosses the x-axis. Now, could we, since I know it goes like this, we could shade, I guess, inside or out. But let's get the details of where it crosses. Right? Let's be complete. Okay. Squaring a binomial. If you've seen my other videos or have me in class, you know my technique. X times x is x squared. Negative 4 times negative 4, positive 16. And then 2 times x times 4. So that's going to be negative 8x. All of that is going to be times 5 and plus 6. All right, you're squaring a binomial. A times A, B times B, 2 times A times B. Okay, what else we got? We have to distribute the 5. So this is going to be 5x squared, whatever 5 times 16 is. 5 times 6 is 30. Carry the 3, 5, 6, 7, 8. 80. And then 5 times negative 8, which is negative 40x, plus 6. Combine like terms. We're going to get, oh, this is negative 5. So distributing the negative 5, we could just say negative 5x squared, negative 80, positive 40x, plus 6, right, because that 6 was outside the parentheses. Okay, combining like terms now, negative 80 and 6, and I'll rewrite it in descending order. So this is going to be 40x minus 74. Okay, so negative 74 is going to cross the y-axis somewhere down by negative 74. Can this be factored? 5 times 74, negative. Okay, so if we plug this into the quadratic equation, we're going to get minus 40 plus or minus square root 40 squared minus 4a, which is negative 5, and c, which is negative 74, all over 2a, 2 times negative 5. All right, so this is definitely calculator work. So when you do the negative version, we're going to get, right, negative version, we're going to get 5.09. So we'll call it 5.1. And I'll do the positive version, 2.9. Okay, so 2.9 puts us here. 5.1, 4, 5.1. So this is actually Okay, and then it crosses at negative 74 way down here. So, okay, let's pick our point, 0, 0. You could pick any point you want, but again, I like using 0, 0. Okay, if I plug in into here, right, because it's y less than and it's dotted. Okay, it's dotted. Plug in 0, 0, 0, 0. Is 0 less than negative 74? No, it's not. 0 is greater than negative 74. So this is false, right? 0, 0, it's false. So that means we shade opposite the other one, which is inside. All right, number 6. Y is greater than or equal, so solid, 2 times x plus 1 times x minus 3. So this is intercept form. So right now, understand that we're looking at the roots. So x equals negative 1, that's an x-intercept. X equals 3, that's an x-intercept. So I know, so let's see, 1, 2, 3, 4. So there's 4 spaces, units in between the roots. That means that the axis of symmetry, it has to be x equals 1, right? Because it's the same, it's equidistant. So somewhere on x equals 1 is the vertex. So let's plug in 1 and see what happens. So 1 plus 1 is 2. 1 minus 3 is negative 2. So 2 times 2 is 4 times 2 is 8, but negative, so negative 8. So at negative 8. And it's positive, so this all opens upward. So let's see, where would it cross the y-axis? Well, that's when x is equal to 0, right? When x is equal to 0. So let's see what it is. So when x is equal to 0, we get 0. So 0 plus 1 is 1. 0 minus 3 is negative 3. So that's nice. 2 times 1 is 2. Times 3 is negative 6. So it crosses at negative 6. And we can reflect that point across. So the parabola is going to look something like this. Now notice 0, 0. It's a horrible parabola, but you get the idea. The 0, 0, the point I'm going to pick is now inside the parabola. So let's pick 0, 0 and see what happens. Okay. Well, we've already done zeros here. So this is going to be, what do we say, negative 6? So is 0 greater than negative 6? Yeah, it is. It is greater than negative 6. So since 0, 0 is on the inside and now it's true, we're going to shade inside. So everything inside is a solution. And it's a solid line, so we're good there. Not bad. Okay, number 7. So here we have 2 graphs, and we want to see where do they overlap or intersect, or even if they overlap or intersect. Maybe they don't. But let's just do them one at a time. So let's look at the first one. So first thing I'm going to do is find the vertex. So this is going to be, so A, B, C. So negative B, or negative B, B is negative 12, all over 2A, which is 3. So the negative is going to cancel, and it's going to be positive 12 over 6, which is basically 2. So x equals 2. Okay, somewhere on this line is the vertex. So let's plug 2 back into this. This is going to be 3, 2 squared, minus 12 times 2, plus 12. All right, 2 squared is 4. 4 times 3 is 12. That's nice. This is going to be 24 plus 12. So 24 minus 24 is 0. So it's 0. And it opens which way? Up. So it opens upward. It crosses the y-axis at 12. So 8, 9, 10, 11, 12. So it crosses up here. That's we can reflect that across. So 1, 2. So up in this area. Okay. 0, 0. Let's test it. 0, 0, 0. Is 0 greater than 12? No, it's not. It's false. So that means we shade inside. Okay. And it's a solid line. Okay, let's look at the next one. This is going to be, it's going to open downward. There is no C, so I know it's going to cross here at 0. So let's look. Let's just look at this. So this is going to be negative x squared plus 4x. All right, instincts are telling me that I can factor out an x, a negative x. I can pull out an x. My thought is that if this is equal to 0, I can figure out the roots. I'm figuring out the roots. That's essentially what I'm doing. Okay, so one of the roots we've already established is right here at x equals 0, right? Because when x is 0, 0 times anything is 0. So that satisfies this. Typically when x squared is negative, like this, I can pull out a negative x. You could leave the negative in, but you know, it's better to pull it out in my opinion. All right, so this is going to be x is equal to negative 4. So when x is equal to negative 4, well, if you pull out a negative, right, look, I'm already getting, I'm thinking something's not right. So if you factor out a negative, that's going to change, right? Because this, that negative is a positive. Okay, so this is going to be positive 4. Okay, so positive 4 puts me there. Which is interesting because, again, it's symmetric. So the vertex is going to be somewhere on the same dotted line, which is 2. So if I plug in 2 to either one of these, I should get where the vertex actually is. So let's plug in 2 into here. So this is going to be negative 2 squared plus 4 times 2. So this is going to be negative 4 plus 8, which is positive 4. So at x equals 4. Okay, it's right here. So it's going to come down this way, down this way. So notice I can't test 0, 0 because it's on the line. I don't know which way to shade. If I plug in 0, 0, it will satisfy. And that's because it's on the line. So I've got to pick something off the line. Let's do 1, 0. 1, 0 is nice. So when x is 1, y is 0. So when this is 0, this is 1, this is 1. So it's going to be 3. All right, number 8. Again, we have 2 inequalities, dotted lines this time. So let's see what happens. These look a little bit easier to manage. Okay, so let's just start with the top one. So y, actually, x squared plus 2x minus 4. I want to figure out the vertex. So this is going to be A, B, C. So we're going to have negative B, which is 2, over 2A. It's negative 1. So x is equal to negative 1. Plug in negative 1 back into here. We're going to get, so negative 1 squared is positive 1, minus 2, minus 4. So this is going to be negative 6, so negative 5. So negative 5. It's positive, so it opens upward, and it crosses the y-axis at negative 4. Okay, let's figure out the roots. Let's figure out the roots. At a glance, is this factorable? Okay, so let's hit it with the quadratic formula. So negative b plus or minus square root of b squared times minus 4 ac, which is 1, negative 4, all over 2a. So 2 times 1. So this is going to be negative 2 plus or minus 4, positive 16, all over 2. So this is root 20. Twenty is really 4 times 5. I can pull a 4 out. So negative 2. I can't pull a 4 out. I can pull out a 2. Right, because 4 is really 2 times 2, so I can pull out a 2. So 2 root 5 all over 2. 2's are going to cancel. Negative 1 plus or minus root 5. So negative 1 plus a little bit, negative 1 minus a little bit. So negative 1 minus root 5 is going to be negative 3.2. And negative 1 plus root 5 is going to be 1.2. So negative 3.2, positive 1.2. Okay, it says 0, 0. So this is going to be y greater than, so 0, 0, 0, 0 greater than negative 4. Yes, it is. So that means I'm going to shade exactly where the point is on the inside. Okay, that's this one. It's greater than, so it's a dotted line. Look at the second one. Second one says x squared minus 4x minus 1. So negative b is negative 4 over 2a. So they're going to cancel, the negatives are. 4 over 2 is just 2, positive. So x equals 2. X equals 2. Somewhere on this graph line is the vertex. So let's plug this back into here. So it's going to be 4 minus 8 minus 1, which is going to be negative 9, right? 4 minus 9 minus 5. So at negative 5, negative 4, negative 5 right here. It opens upward. It's going to open upward this way. Let's see where it crosses the x-axis. Quadratic formula for sure. So minus b plus or minus the square root negative b squared minus 4a, which is 1, c negative 1, all over 2a. Okay, 4 plus or minus 16 plus 4. So 16 plus 4 is 20. Again, 20 is going to be 2 root 5. We just said that. So 4 plus or minus 2 root 5 all over 2. So 2's are going to cancel. So we're going to get 2 plus or minus root 5. Okay, let's see what those values are. So 2 plus root 5 is, so one answer, 4.2. Negative 0.2. So at negative 0.2 and 4.2. It crosses at negative 1. So that's nice. Oh, I guess we could have reflected that across here. Okay. And let's test 0, 0, which is barely inside, but it's definitely inside. So if I plug in 0, 0, I'm going to get y is greater than, so 0, 0, 0, negative 1. So is 0 greater than negative 1? Yeah, it is. So again, this is dotted. And we want to shade inside, right, inside. But we only care about the part where they overlap, right, where they overlap. So right in here. So that satisfies both. More or less. That was a fun one. All right, number 9. On the left below, the area under the parabola and above the horizontal line, the area of this section is 2/3 base times height. So the base, we'll call this the base, the height from the vertex. So 2/3 times this times that. That'll give me the area. Okay, so let's plot these two. So y greater than or equal to 0. So that's basically going to be the x-axis. It's solid. And then we want y less than or equal solid line. Negative x squared plus 4x. So the first thing I'm thinking is I want to factor this out. I feel like this is what we did earlier. So let's see. Negative x, x minus 4. Right, if I factor it out, it says equal to 0. This is going to be x is equal to 0 and x is equal to 4. So x equals 0, x equals 1, 2, 3, 4. Axis of symmetry is going to be exactly in the middle, which is x equals 2. So when I plug in 2, I'm going to get, we just did this, but I'm going to do it again. So this is going to be 2 squared, which is negative 4, plus 8, which we see is positive 4. So that x equals positive 4, 1, 2, 3, 4. Okay. We're looking for the area of this. So 2/3 base times height. So the base is going to be this section, which is 4. So 2/3 times 4 times the height. of the vertex, which in this case is 1, 2, 3, 4 also. So the area, 4 times 4 is 16, times 2 is 32, all over 3. So the area is going to be 32 over 3. Okay, that's it. Minimal mistakes. Yeah, if you found this useful, be sure to give me a thumbs up.